Hello everyone, I Abhishek Mishal from CSBT Bhilai welcome you to on this massive online course Fundamental of Digital Communication System and its Application. Fundamental of Communication System and its Application. Today we will start on a fascinating journey into the world of digital communication. In previous lecture, you study about the communication system, which is the basic communication and it is called analog communication. In the last lecture of the analog communication, you study the advantage and limitation application of analog communication. To overcome the limitation of analog communication, the new communication system was introduced that is called digital communication. In this lecture, we study the fundamental concept, historical evolution, key component and the impact of digital communication on modern society. By the end of this lecture, you will have a comprehensive understanding of how digital communication systems work, their significance and their future prospect. Our discussion will be over the fundamental concept, historical evolution, key components, impact of digital communication on modern society. By the end of this lecture, you will have a comprehensive understanding of how digital communication systems work, their significance and their future prospect. The first topic is historical evolution of communication. First, the communication start by the human communication has evolved dramatically over the millennia. Early from include cave painting, smoke signal and carrier pigeon. These methods are simple but limited in the range, speed and reliability. As you already study the history of communication, so we now go directly to the digital revolution. The latter half of the 20th century witnessed the digital revolution, the invention of transistor in 1947 and subsequent development of integrated circuit by paved the way of modern digital communication. The transmission from analog to digital system began driven by a need for more efficient, reliable and scalable communication method. Now, the other important point is difference between analog versus digital signal. To understand digital communication, it is essential to distinguish between analog and digital signal. The difference between analog and digital signal is the fundamental of grasping how modern communication systems operate. Below, the key distinctions between these two types of signals are: first, the analog signal. Here these signals are differentiated by the different parameters, like first parameter is nature of signal. First, analog signals are continuous waveforms that vary over the time. They represent information using a continuous range of value. The second parameter is the smooth variation. These signals can take on any value within a range leading to smooth and continuous changes. Third parameter is the representation. Analog signals typically represent physical quantities such as sound, light, temperature or voltage. Example include the human voice which can be recorded or by vinyl records or tape, and analog radio and TV broadcast. Signal quality and noise. Noise susceptibility. Analog signals are highly susceptible to noise and interference, which can degrade the signal quality. Any alternation in the signal path can cause a loss of information. The second is signal degradation. Over long distance, analog signals tend to degrade, resulting in reduced clarity and quality. Storage and transmission. These signals are stored in storage media, like analog data is stored on media such as vinyl record, magnetic tapes, and VHS tape. Transmission. Analog signals are transmitted over traditional medium like coaxial cable, twisted pair cable or radio wave bandwidth. The bandwidth of analog signal typically require a higher bandwidth to transmit the same amount of information compared to digital signal. Now we discuss the digital signal. The nature of digital signal is discrete. Digital signal are discrete and consist of binary values 0 and 1. These values represent data in distinct steps rather than a continuous flow. The second is step changes. Changes of digital signal are abrupt and occur in a fixed step. Now, the digital signal are represented in a binary data form. Digital signal can be easily processed, stored and transmitted to any other device. The example of these signals are digital audio recording, digital video and data transmitted over the internet. The quality of signals and noise resistance are less susceptible to noise and interface. Error can often be detected and corrected through various digital techniques. Maintain the signal integrity also. Now, if we discuss about the representation of digital signal, these signal can be represented at interval which prevent the degradation over a long distance, ensuring high quality transmission, storage and transmission. These digital data is stored on media such as hard drive, solid state drive and optical disk. The transmission of digital signal are transmitted by over modern medium like fiber optics, cable, ethernet, wireless network like cellular or Wi-Fi. The bandwidth, because of the efficient use of the bandwidth, digital signal can be compressed, allowing more efficient use of the bandwidth. The efficiency is essential for high-speed data transmission and large-scale data storage. The summarized difference between this is shown in the below table. Now, we discuss the key concept of digital communication system. A typical digital communication system have the following block diagram, which is shown in the figure. Our digital communication is designed to transmit information efficiently for a source to destination. The block diagram of digital communication system typically consists of the following key component. The first component and very important component is source. Information source, the origin of data to be transmitted. It could be text, audio, video or any other data. Source encoder, data compression, reduce redundancy in the data to make transmission more efficient. Source coding, convert the data into digital signal. The second is channel encoder. Error detection and correction is the main work of this channel. It adds redundancy to the data to detect and correct error using transmission. Modulator, digital modulation, convert the digital signal into the waveform suitable for transmission over the communication channel. Common modulation techniques include ASK, PSK and QAM. These techniques will be discussed in the next lectures. Now, the transmission medium. The medium over which the signal is transmitted, it could be wired like coaxial cable, fiber optics or wireless. And if we discuss about the noise interference, any unwanted signal that distort the transmitted signal causing potential error in received data. The next is demodulator, signal demodulation, that is convert the received waveform back into digital signal. Now, next is channel decoder, error correction. Now, once again we detect and correct the error in the received data using the redundancy added in the channel encoder. Now, after that we use the source decoder, a data decompression, restore the original data format from the compressed form. Now, about the source decoder, now finally convert the digital signal back into the original form and we send this signal to the destination. Or it will be stored in information sink, that is the end point where the received data is used or processed. Now, I will once again explain the each block diagram. That's why you will be understand the basic block diagram of digital communication. The first is information source. This is the origin of the message or data that need to be communicated. It generated the data in its original form. Now, the second is source encoder. The source encoder compress and convert the data into a digital format suitable for transmission. This might involve removing redundancy and representing the data into binary form. Now, we discuss about the channel encoder. The channel encoder add extra bits to data to help in error detection and correction. Technique like Hamming code, Reed-Solomon code, etc. are used to achieve this. Now, if we discuss about the modulators, the modulator convert the digital signal into a form of a suitable for transmission over the chosen medium. This involves mapping the binary data onto analog waveform using modulation scheme. The next is transmission medium. This is the physical path between the transmitter and the receiver. It could be wired medium like cable or wireless medium like air or space. Now, if we tell about the noise, noise represents any external interference that can distort the transmitted signal, potentially causing error. Now, if we discuss about the demodulator at the receiver and convert the received analog waveform back into the digital signal. Channel decoder. The channel decoder processes the receive the signal to detect and correct the error utilizing the redundancy added by the channel encoder. Now, the last important point is the source decoder. The source decoder decompresses the converting digital signal back to its original. Information sink. This is the final destination where the receive the data it utilize, display or store. So, I hope you understand the basic block diagram of digital communication properly. Now, we move to the another important topic, that is modulation and demodulation. Modulation and demodulation is very important. So, here we discuss about some technique. Modulation is the process of varying a carrier signal in order to transmit the data in digital communication. We use various modulation schemes such as amplitude shifting, that is called ASK, frequency shifting, we are called shortly as a FSK, and phase shifting, that is FSK. Demodulation is the reverse process where the received signal is converted back to its original form. This is essential for accurate retrieval of information. The type of digital communication are wired communication. Wired communication involves the transmission of data over a physical cable. Common type of communications are include first, that is two-state pair cable used in telephone network and Ethernet. Coaxial cables used in cable TV and internet connection. Fiber optic cable use light signal to transmit data at high speed over long distance. They offer high bandwidth and less susceptible to interference. Now, the another type of communication is wireless communication. Wireless communication use electromagnetic waves to transmit data through the air. Key example include radio wave used in AM, FM, which is called amplitude modulation and frequency modulation, television and mobile phone, microwave used in satellite communication and Wi-Fi, infrared used in remote control and short range communication. The very vast communication is the satellite communication. Satellite orbit the earth, relay communication signal across vast distance. They play a crucial role in global broadcasting, weather forecasting and GPS navigation. The another important and popular type of communication is cellular communication. Cellular networks divided geographically area into cell. These base stations enabling widespread and mobile connectivity. The evolution cellular technology from 1G to 5G has dramatically increased the data rates and connectivity. Now, if we discuss about the application of digital communication, the first application of digital communication is Internet and World Wide Web. The Internet, a global network to interconnected computers, relies on digital communication protocol like TCP/IP. The World Wide Web is an application of the Internet enabling the sharing of information through the web page. The next is social media. Social media platform like Twitter, Facebook and Instagram leverage digital communication to connect people, share content and facilitate real-time interaction. Now, digital communication also play an important role in e-commerce. E-commerce platform like Amazon and Flipkart use digital communication for online transaction, enabling business or reach the customer in worldwide. Streaming services like Netflix, YouTube and Spotify rely on digital communication to deliver high quality audio and video content on the demand. Now, if we discuss the telecommunication services including voice, call, messaging and video conferencing are powered by digital communication technology. Now, if we discuss about the future trend in digital communication, that is 5G and beyond, the roll out of the 5G network promise faster data rates, lower latency and increase the connectivity. Future developments aim at 6G will further enhance communication capability and enable the advanced application like smart city and automatic vehicles. Now, if we discuss the Internet of Things, the IoT refer to the interconnected network of physical devices that communicate and exchange the data and its application in smart home, healthcare and transition and industry. Quantum communication. Quantum communication leverages the principle of quantum mechanics to achieve ultra-secure communication. Quantum key distribution is the one such application provide theoretically unbreakable encryption. Now, if we didn't talk about the artificial intelligence, it will be very injustice for digital communication if we didn't talk about the artificial intelligence. AI and I machine learning are increasing being integrated into communication system to optimize the network performance and enhance the security and enable the intelligent discussion making. While digital communication offers numerous benefits such as high efficiency, speed and convenience into all convenience, it is also have several disadvantages. These disadvantages can impact effectiveness, security and accessibility of communication system. Below are here we discuss the some key disadvantage of digital communication. Now we discuss the major issue, that is security issue. Cyber security threats are major and very important threats which is people are suffering from daily life. Hacking and cyber attacks. Digital communication systems are susceptible to hacking, cyber attack and other malicious activity that can compromise sensitive data and disturb services. The data breach. High profile data breaches expose personal and sensitive information leading to privacy violation and financial loss. Phishing and social engineering. These tactics exploit human psychology to gain unauthorized access of information, positioning insufficient security risk. Now, if we discuss the encryption and key management, it is the another most important topic, and here for digital communication or modern communication it will be very much essential. The complexity. Implementing robust encryption method can be complex and resource intensive, requiring advanced technical knowledge, and infrastructure. Key management. Effective key management is crucial for maintaining and security of encrypted data, but it can be challenging to manage securely. Now, if we discuss about the signal quality, interference, digital signal can susceptible to interference for other electronics device and environment factor which can degrade the signal quality. Distance limitation. The quality of digital signal can be degraded over long distance without proper amplification or regeneration. Now, if we discuss the cost, it is about the cost. It is the initial investment. Basically, the infrastructure cost set for this is very high. Setting up digital communication system requires significant initial investment in infrastructure, including hardware, software, and network equipment, and it also takes time. For example, you are using the Geo 5G, but it's for establishment these network, Geo have a 2 to 4 year for the establishing basic infrastructure. So it's take too much time and too much cost affecting. Now, the maintenance cost. Ongoing cost for maintenance, upgrade, and technical support can be essential. Now, subscription fees. The service cost. Many digital communication services such as high-speed internet, cloud storage, and advanced communication tool come with subscription fee that can add up over. Energy consumption. The power requirement of digital communication system, especially data center and networking infrastructure, is high. It consumes substantial amount of energy, leading to high operation cost and environment impact. Sustainability concern. This is a growing need to develop more energy efficient technology to reduce the carbon footprint of digital communication system. Now, after the discussion of digital communication advantage and disadvantage, the next step or the first step of digital communication is the discrete digital communication, where it is the step where the analog signal is start converting to the digital communication. First, the analog signal is converted into the discrete signal, then it converted into the digital signal. So, it is unjustified if we forget the discrete digital communication. So, here I will give a brief overview about the discrete communication system. In this system, the digital modulation, we have to understand the difference between the discrete and digital. Digital modulation and discrete modulation are the key concept in signal processing and communication, often used interchangeably but distinct nuisance. Now, first discuss the discrete modulation. The discrete modulation refers to a modulation method that deal with the discrete value or state. This term can encompass digital modulation but also include certain analog techniques. For example, if we discuss about the pulse code modulation, which convert the analog signal into discrete signal level, and delta modulation, which involve the difference between the successive sample into discrete step. Discrete modulation is applicable in both digital and communications and analog to digital conversion process. Now, if we discuss about the digital modulation involves modulating an analog carrier signal using digital data. Techniques such as amplitude shift keying, frequency shift keying, and phase shift keying, and quadrature amplitude modulation, that is called QAM, encode binary or multi-level digital information onto a high frequency carrier wave. This method is widely used in digital communication systems like cellular network, Wi-Fi, and digital broadcasting, focusing on efficient and reliable data transmission. Now, if we talk about the key difference between the digital communication and discrete communication is these are the digital communication is especially about encoding digital data onto an analog carrier. In the contrast, discrete modulation cover a broader range, including any modulation involved with discrete value, where in digital or certain analog contexts, digital modulation is subset of discrete modulation, primarily focusing on transmission of digital data. Now, if we discuss the type of signal, because very important is the signal. So, first is the type of signal is digital modulation, especially involve the modulation of a carrier wave using digital data like binary or multi-level data. In the discrete modulation can refer to any modulation technique involve discrete state or value, including both digital and certain analog method. Now, if we discuss about the modulation technique, in the digital modulation, they are focused on the technique like ASK, FSK, PSK and QAM, which encode digital information onto an analog carrier wave. In the discrete modulation includes technique like PCM and DM that deal with the discrete value in both analog and digital context. Now, if we discuss the application, here the digital modulation widely used in digital communication systems such as a cellular network, Wi-Fi, satellite communication and digital broadcasting. If we discuss about the discrete modulation used in both digital communication and analog to digital conversion process, include audio and video signal processing. If we discuss about the encoding and transmission, digital modulation encodes binary data directly onto a high frequency carrier waves suitable for efficient and high speed data transmission. In the discrete modulation may involve encoding of analog signal into discrete level before modulation or directly using discrete modulation techniques. Modulation techniques are the method used to encode the information onto a carrier signal. The three common pulse modulation techniques are pulse amplitude modulation, pulse position modulation and pulse width modulation. It is the very important and essential technique of discrete modulation technique. It is very much an important technique of discrete communication system. So, let's a brief discussion of these techniques are also included in this lecture. So, let's start. The first technique is pulse amplitude modulation. Pulse amplitude modulations involve varying the amplitude of a series of pulses to encode information. Each pulse amplitude is directly proportional to the amplitude of analog signal at a specific sampling stand. The principle of the pulse amplitude modulation is the pulse represent the signal's amplitude. Application used in digital communication system like internet and in some form of digital signal processing. The advantage of this communication system is the advantage of this technique is simple to implement, straightforward modulation and demodulation process. Disadvantage: sensitive to noise and interference, as a noise can affect the amplitude of pulse. Now, the next technique is pulse position modulation, that is called PPM. Pulse position modulation encode information by varying the position of each pulse relative to a reference. The amplitude and the width of pulse remain constant, but the timing of each pulse change according to the modulating signal. Now, the principle: the position of each pulse represent the signal's amplitude at a specific time. Application used in optical communication, remote control system and time division multiplexing. Advantage: less sensitive to noise compared to the pulse amplitude modulation, as information is encoded in the pulse position. Now, if we discuss the disadvantage, require precise synchronization between the transmitter and receiver, more complex receiver design. Now we discuss the third technique, that is pulse width modulation. Pulse width modulation involves varying the width or duration of each pulse while keeping the amplitude and position are constant. While keeping the amplitude and position constant, the width of the pulse corresponding to the amplitude of analog signal. The principle, the duration of each pulse is proportional to the signal's amplitude. Application widely used in power control, motor control, audio signal processing and voltage regulation. The advantage is efficient in terms of power, uses simple implementation and good noise immunity. The disadvantage, generate high frequency harmonic which may require filtering, potential distortion if the pulse width is not accurately controlled. Here I conclude my lecture. In this lecture, we cover the following topic, that is the history of digital communication, basic difference between analog and digital signals, concept of digital communication and block diagram, type of digital communication, application of digital communication, the region where the digital communicated need improvement, core concept of discrete communication, the type of discrete modulation technique like pulse amplitude modulation, pulse position modulation and pulse width modulation. So, digital communication is cornerstone of the modern society, transforming how he connect, share information and conduct business. From the historical evolution to the technique, technique and future trends. Understanding digital communication is essential for navigating the digital age as we continue to innovative and expand our digital capability. It is crucial to address the challenges and ensure that these technology benefits of all humanity. So let's welcome you to this era of digital communication. Thank you for your attention.